Welcome. Today, we're going to solve for x in a polynomial equation. This problem is a classic and can be quite tricky if you don't know the right approach. Our goal is to find all the values of x that satisfy the equation x cubed plus x equals 350. By the end of this video, you will be able to: first, you'll be able to recognize when a problem might have a simple integer solution. Second, you'll learn a technique called substitution to solve cubic equations that might seem complex at first glance. And third, you'll be able to confirm your solutions by plugging them back into the original equation. So how can we start with this? Take a moment to think about what you might try first. A very common first step is to rearrange the equation to set it equal to 0. We can subtract 3 on 50 from both sides to get x cubed plus x minus 350 equals 0. Our objective here is to find the roots of this polynomial. One strategy for polynomials is to test for integer roots using the rational root theorem. However, there's a faster way in this specific case: estimation. Let's try a few integer values for x and see if we can find a root. We want x cubed plus x to be 350. Let's start with x equals 5. 5 cubed is 125. Plus 5 is 130. That's too small. Let's try a slightly larger number, say x equals 6. 6 cubed is 216. Plus 6 is 222. Still too small. What about x equals 7? 7 cubed is 343. Plus 7 is exactly 350. We found a solution. X equals 7 is an integer root. This method is great for finding simple integer roots, which are a common feature in many contest problems. We've achieved our first objective of finding an integer solution by using estimation. So, we've established that x equals 7 is one solution. But are there others? In general, a cubic equation can have up to 3 solutions. To find any remaining solutions, we can factor our polynomial using the root we just found. If x equals 7 is a root, then x minus 7 must be a factor of our polynomial. We can use polynomial long division or synthetic division to divide our polynomial by x minus 7. Let's use the substitution method instead, which can be more intuitive for a problem like this. Our goal is to rewrite the expression x cubed plus x minus 350 so that x minus 7 is clearly a factor. We can do this by cleverly adding and subtracting terms. Watch how this works. Our target is to create an x cubed minus 7x squared term. We start by rewriting x cubed plus x minus 350. Now let's subtract 7x squared and immediately add 7x squared to keep the value the same. This doesn't change the expression, but it allows us to factor the first part. From the first two terms, we can factor out x squared, leaving us with x squared times the quantity x minus 7. This is exactly what we wanted. Now we repeat this process with the remaining terms. Our new goal is to create a 7x squared minus 49x term. Let's focus on the 7x squared plus x minus 350. We'll subtract 49x and add 49. From the terms involving x squared and the new 49x term, we can factor out 7x, leaving us with 7x times the quantity x minus 7. Perfect. We're almost done. We just need to handle the last two terms, 50x minus 350. Is x minus 7 a factor of this? Let's factor out 50. We get 50 times x minus 7. Yes, it is. 350 is 50 times 7. Now, look at what we have. We have achieved our second objective. The entire polynomial is written as a sum of 3 terms, and each term clearly has a factor of x minus 7. Because every term has a factor of x minus 7, we can now factor it out of the entire expression. Factoring out x minus 7 leaves us with x minus 7 times the quantity, x squared plus 7x plus 50. This equals 0. Now we have the equation in a factored form. For the product of two numbers to be 0, at least one of them must be 0. This gives us two possibilities. Possibility 1, x minus 7 equals 0, which we already knew gives us x equals 7. Possibility 2, x squared plus 7x plus 50 equals 0. To find the solutions for this quadratic, we can use the quadratic formula. The quadratic formula states that x equals negative b plus or minus the square root of b squared minus 4s, all divided by 2a. In our equation, a is 1, b is 7, and c is 50. Let's substitute these values into the formula. Let's calculate the value inside the square root, which is called the discriminant. We have 49 minus 200. This gives us negative 151. the discriminant is negative. A negative discriminant tells us that the quadratic equation has no real number solutions. It has two complex conjugate solutions. For this video, we'll focus on real solutions. This confirms that x equals 7 is the only real number solution to our original equation. We have successfully found the complete set of real solutions, achieving our second objective. Before we wrap up, let's complete our third objective, verifying our answer. We need to check if x equals 7 truly satisfies the original equation. Let's plug x equals 7 back into the equation x cubed plus x equals 350. This gives us 7 cubed plus 7 on the left side. 7 cubed is 343, and 343 plus 7 is 350. Since 350 equals 350, our solution is correct. We have verified our answer. Let's recap what we accomplished today. We took a cubic equation that seemed difficult to solve. First, we estimated and found a simple integer root, x equals 7. Second, we used a clever substitution technique to factor the polynomial. Third, we used the quadratic formula to show that there were no other real solutions. And finally, we verified our answer. This problem demonstrates that estimation can be a powerful first step in solving polynomial equations. Thank you for watching.